Yeah, hey everyone. Thanks for giving us some time today. Looking forward to sharing with you about how you can use SafeLiShare in our confidential computing environment to enhance your ability to use different tools inside of hyperscaler clouds. So stay tuned. It's going to be an exciting conversation.
Yeah, looking forward to it. Tim, as you talk to a lot of people in the machine learning and AI space, that a lot of time is spent in refining the data, cleaning the data, detecting anomalies in the data. And that's where 80–90% of the effort happens to be. Is that what you hear as you talk to customers uh, and various other prospects?
Absolutely. Yeah, it's a big challenge to not only find clean data, but even just to get access to data a lot of times. I've heard many people have had the chance to talk with over the last few months say that upwards of 95% of the data that they want to be able to access is just not accessible because it's not publicly available. It's got, it's behind walls for good reasons, like privacy, intellectual property, regulatory requirements, legal requirements, etc. So that data lives behind those walls and, on purpose and by design, but because it's behind those walls, it can't really be used for model training, model development. Then once you get access to that data, what does it look like? And how do you clean it up? And how do you get it into a format and into a usable schema so that you can then use it to train your model. So those are big challenges that are out there as generative AI tools continue to take off, as everybody's building models to solve different problems, whether it's in research, maybe it's in fraud detection, maybe it's in just some simple use cases like identifying customers, creating healthcare longitudinal records. These are all the kinds of challenges that we're hearing out there. And yeah, the data availability and then the data hygiene, maybe for lack of a better term, are the really big challenges in creating these models for folks.
Yeah, no. So usually you one sort of gets this impression that it's mostly about training the model and then deploying the model. But even if you have trained the model, before you can deploy, you have to performance test the model. And then you oftentimes, most times in fact, have to go back and re-clean the data and figure out uh, where perhaps you can do some tweaking and retraining, etc. And not only that, you may have to redimension the data sets that you use for the training purpose, and you have to do some hyperparameter tuning of the model until you finally get something with a sort of acceptable performance. So it's not only all the effort in data management that you get to the point of having to of using the data to train the model, but also you have to go back and do most of it again in a repeated iterative sort of fashion.
Yeah, absolutely. I think one great example of that has come up with a lot of the healthcare and research entities that we're dealing with, where they've trained a model to look for things like indicators of disease within that come up within certain factors within blood tests or within modality reports from imaging tools like MRI, CT scans, things like that. And they've got a good model train built, but not all people are created equal in terms of our health, of our genetics, of our environments. So what may be a very reliable model test run against a group of people living in the United States of America may not work as well when I go run it against the same types of data in from people who live in France or in India or China. Because again, there's genetic differences, there's environmental differences, all kinds of things that go on, right? So just like you said, right, the training process really never ends. It's an iterative, ongoing process. Especially if you're looking, as many organizations are, to try to build a globally applicable model, or as widely an applicable model as possible. You have to get lots of data sources in play, and it's not a one and done scenario, unfortunately.
Yeah.
Lots of work involved.
So now let's look at this in somewhat more concrete terms. You have a data pipeline, and you are massaging and anonymizing and cleaning the data and aggregating and collecting the data and all the different data sources. And that's, in some sense, very crucial work. SafeLiShare provides a platform that allows you to have trust in this process, or confidentiality in this process, as you're doing. So what is this notion of confidential computing that SafeLiShare uses, and how does that apply to the process of data management, even before you get to the training phase?
Yeah, absolutely. Great question. So if you think about, if I want to put some healthcare data or financial data or any other data that contains information that we just don't want to get out there, and I'm going to do any kind of processing with it. And this, like you said, could be language model training, but could be just some very simple processing I want to do with it. The fact that that data is sensitive means that I need to protect it. And we've gotten very good over the years as information security professionals and data professionals at thinking about things like encryption at rest and encryption in transit. But what about encryption during processing? And this becomes particularly important as we lean further into adopting public cloud and hyperscaler technologies and infrastructures to do that processing. And of course, we want to do it there because, hey, let's be honest. Microsoft, Amazon, Google, they're way better at running data centers and running large compute clusters than anybody else in the world. And so we want to leverage their expertise. We want to leverage the resources that they have. There's numerous economic reasons for us to do that. But what about security? What about making sure that we can trust that there's not access to that data inadvertently or on purpose? So that's where confidential computing comes in that it gives you that trusted execution environment for computations to be run against data, so that three very important things happen. Number one is I know the code that's running against the data, right? It's been signed. It's been, we understand what's happening in that process, in that computation is very well understood, very well defined. No surprises, no bugs, no malware, anything like that. Number two, the process itself is encrypted in memory. So even if someone was able to get into that environment, whether it's your on-prem compute or whether it's a compute in a hyperscaler, and dump that memory somehow, they're still not going to be able to reassemble that data because it's encrypted at the processing layer. And then thirdly, everything that happens inside of a trusted execution environment is fully logged, so that you have full audit trail of everything that's going on. And these logs are again encrypted and signed at the hardware layer by the technology that's providing this encryption, the underlying processing technology that's providing this layer of protection during the execution. So you've got three extra layers of protection around your data for any computation. Again, whether that's something simple like a set intersection, or whether it's something much more, I don't want to say complex, but something maybe a little more interesting like a model training. Regardless, your data is protected during that computation process by that trusted execution environment in the three ways that I just outlined.
So you have talked about the case where the computation is happening on the platform that is based on confidential computing or a trusted execution environment.
Yeah.
But of course, a lot of cloud providers, and you mentioned a few of them in your just now, Amazon, Microsoft Azure, and Google, not only provide these confidential computing infrastructure, but also provide services that allow you to use and those services for model training and model deployment. For example, on AWS, there is a service called SageMaker that will train model that you can use for training models as long as you can provide the training data sets, etc. Do you have any? And now in this particular case, the compute doesn't happen in your data pipeline, in your account. The compute is happening in a cloud service, using a cloud service. And so what are the confidentiality requirements? And do you have an example that you could show to our listeners?
Yeah, absolutely. So let me actually share an architectural diagram with you and with our listeners here, and we can walk through how this example would work. So, like you said, there are confidential computing capabilities in platforms like AWS, and certainly Azure, Google, other cloud providers have that service available as well. The challenge is in provisioning that toolkit, and so this is one of the value adds that SafeLiShare brings to our customers, is that we make the provisioning of all the different resources that are required to run computations within a trusted execution environment very straightforward, very simple, right? So, and we can make it very simple for non-programmatic users, people who want a GUI, who can click upload, done, run computation, done. Like they want a simple web interface to be able to run these things. And of course, we can also accommodate folks who are very comfortable doing things in a programmatic fashion, whether that's using tools like serverless tools like AWS Lambda, like the example we'll walk through here in just a moment, or using their own API integrations and creating their own API calls into a SafeLiShare environment. So you've got lots of options of how you want to do this, but what we do is we make the confidential computing process easy for you and for your users. So you don't have to worry about, did I configure everything right? Did I miss something? Which services do I need? Those kinds of things, right? We set it all up for you, running in a platform as a service. So that inside, in this case, we're looking at an AWS example, but we can do the same thing in the other hyperscaler platforms as well. So Azure, Google, and we can even extend this on-prem if that's something that's required for you to do as well. So let's walk through an example. So the second part of your question, Shamim, was around how do I leverage some of these services that they're not compute workloads. So I couldn't maybe run these in an SEV instance, or a Nitro instance. Those are the options that you have when you're talking about Amazon for confidential computing, SEV and Nitro, right? So but there are services out there that you may want to leverage, particularly in an application like model training, that aren't going to run on those confidential computing nodes or confidential computing environments inside of Amazon. So what if I want to or need to leverage a tool like SageMaker? So here's an example of something that we've built for our customers to be able to not only leverage that in a secure way, a tool like SageMaker, but also be able to do this in an iterative process. So as mentioned earlier, right, that these things are very iterative, and it's not a one and done scenario. You need to maybe run these things several times across multiple models, across multiple data sets, as you continue to refine the model, sharpen the knife, if you will. So let's walk through this example. Starts with, well, we could really start, it's a cycle, so we could really start it anywhere, but arbitrarily chosen to start it at the Lambda function side, where the Dynamo database, or the, if you're talking about the very first time this happens, a user, flips the switch and says, hey, let's start this process of training this model. So Lambda functions are going to call out to, in this case, the simple queue service to queue up the model training. That's going to send instructions to the SafeLiShare confidential computing platform, and specifically to the model training clean room that's been provisioned inside the SafeLiShare environment. Again, this is all running inside this organization's AWS cloud environment. And we could talk in a minute about how we could expand that into multi-cloud, things like that as well, if that's interesting. But for this example, let's keep it all in one AWS account for the purposes of discussion. So that model loader begins to run inside of the clean room, and it's going to trigger to SageMaker to say, hey, pull this model from an S3 bucket. That S3 bucket is encrypted, and begin to run this. So SageMaker is going to have to decrypt the model to run it. Now, this model is actually going to be double encrypted. So the data is encrypted, but then the key to decrypt the data is also encrypted. This is a well-known approach called envelope encryption, right? So we've got a data encryption key and we have a key encryption key. The data encryption key is going to be stored inside of the Amazon KMS, right? So the S3 bucket pulls from the KMS. SageMaker is able to get the data encryption key. However, that data encryption key is encrypted. This is the envelope, right? This is the outside encryption layer. And so we need to also be able to decrypt the data encryption key so that as SageMaker is processing this data, it's able to decrypt it in memory and not have to store this information in a unencrypted fashion. So that key is now stored inside the confidential computing key store. That's step number 5. So the model loader is able to pull the key encryption key from inside the confidential computing platform and then provide that to SageMaker to allow for SageMaker to run the model and train the model. And then from there, it's kind of what do you want to do, right? Again, we talked about how this is normally an iterative process. So, at that point, if you're done, you're done. But more likely than not, this is just one step of many. So we update the database that, hey, we've gone through this training sequence. Let's initiate the next training sequence. And that may be against a different set of data. That may be, there may be other ways you want to approach it, but that's how that instruction loop runs. Yes, go ahead.
What is the basic problem that is being solved here?
Yeah, so SageMaker, and again, there are other tools like SageMaker within the other hyperscaler environments, but they're tools that are already built for this purpose, right? So rather than having to, build tools to train your model and natively, you've already got something out there that's very good at this. So why not leverage that? Well, the why you can't just run this directly is because the data that you need to train against is very sensitive, and so you can't. It's not. I want to say you can't. You could. You shouldn't push that data into a non-confidential environment.
I think that is the key.
So this is extending the trust. Sorry, go ahead. Yes.
You are not only protecting the data, you are not only protecting the model, because the model is encrypted inside the confidential computing platform, and the model is, but the data is also protected in a completely encrypted bucket. So
exactly. Yes.
So
this is 2 layers or two areas of protection, right? So we're protecting, and if you're thinking about this in a collaborative approach, which is really why it's called SafeLiShare, right? Is because we're assuming that you're going to have model creators and you're going to have data owners, and they want to be able to meet in the middle. That's not exactly this use case, but it's a similar type of thing, right? Where we're able to protect both entities, the intellectual property, the data property of both the model and the data at the same time, and make sure that while that computation interaction occurs for something like model training, there isn't cross-pollination, there isn't leakage of any intellectual property or any sensitive information from one side to the other. Exactly.
At the state of the art in confidential computing is that GPUs are not supported, and if this model happens to require the use of GPUs, it may be one more reason, a sort of additional reason to go to SageMaker and have it use the services of a GPU. But then the trust model becomes a little more complicated. You have trust. You have zero trust between the two collaborating partners, but you trust the cloud service to be secure and to have access to the data, because the GPU is not a secure computing environment, at least in this particular example. There is a lot of interest now in generative AI, and in that particular case, perhaps you could talk a little bit about a use case in which you are fine-tuning a model that has been generated by using a shared data set from a collaborating partner.
Yeah, absolutely. So it's actually a very similar architecture and deployment, in that, instead of using the SageMaker service within AWS in this case, we could use a service like Bedrock. So this is actually a very extensible solution, because it could extend to many different services inside of AWS to accomplish whatever it is that you need to do within the context of your model training, or perhaps even other types of computations that you want to run. And it's even more flexible than that, because this architecture could actually be applied. We just changed the service we're using, right? Instead of S3, now we're using blobs, and we use a couple different other services in Azure. But this same type of architecture and solution could be deployed in Azure and Google. So this is very flexible. And in fact, one of the neat things we're seeing with some of our healthcare research partners that we're working with is they're actually using this to support multi-cloud model training. So it might be that healthcare system A has their data in Google, and healthcare system B has theirs in Azure, and C has theirs in AWS, and D is on-prem, and I need to go be able to touch potentially all of these. Great, that's amazing. You can absolutely do that. Using this iterative process and using a SafeLiShare clean room that's deployed in each one of those environments. You can use a process very similar to this and extend leverage that multi-cloud deployment. So this, while our example here is we just use AWS because it's probably the most widely deployed. We're not in any way limited to those specific services or that specific hyperscaler. This is a very flexible solution, and in fact, it's really designed to be a multi-cloud deployment scenario. And the big benefit, besides the ones we've already talked about in terms of the ease of deployment, the enhanced security of data and model protections, the other big benefit to leveraging a solution like this in a multi-cloud environment is the ability to avoid data transfer costs. So you're not having to pay as that data or even that model is moving in and out of multiple clouds. So because we're able to do the interaction securely within the context of each cloud, you're not having to move information around and not only incur the privacy and data protection risks that are involved there, but also just incurring the costs, the non-trivial costs in many cases of moving large data sets, particularly when you start talking about things like medical, large data sets of medical images or genomic data.
You are referring to the capability of controlling the data egress charges.
Exactly. Yes, the data egress charges from moving around. So that's a big advantage to looking at a solution like this beyond the privacy and security concerns. There's a great economic story to be told by a solution like this as well.
So what I find interesting is that in both the examples that you shared, you were using a confidential computing platform to deliver a set of keys that controlled an asset that was shared by a collaborating partner. In one case, it was a model. In the other case, it was a data set. But in both cases, the shared asset was completely encrypted, and it was being protected by a set of keys, and the keys were being protected by a confidential computing platform.
So it protects all the people in the transaction. It's a real win-win scenario as we look at this specific use case of model training. And then, the other thing that's a win is, for the hyperscalers themselves, because the existing tools that they have, like a Bedrock or a SageMaker or the equivalent tools in Azure or Google, they don't have to not leverage those because they're not running on confidential computing today, right? So now all of these toolkits that researchers that AI model creators are used to using, they get to continue to use the same tools they have, but in a more secure, more protected way. So it's a win for those people who are creating models as well, and as well, and it's a big win for the people who are supposed to secure all of these transactions, right? The data protection specialists at all of these different healthcare, financial firms, et cetera, who are charged with keeping all of this data and all these models safe and not stepping outside of where they're supposed to be. So lot of great benefits to a solution like this for a lot of different parties that are involved. One question we get a lot is, so how would I deploy something like this? The answer is really a very simple deployment from a whichever cloud provider you want to deploy into. We're able to handle all the provisioning of the SafeLiShare computing platform. Again, this runs 100% inside your compute environment, whether that's public cloud, private cloud. So all of that is provision for you as part of the SafeLiShare deployment. From there, we can either provide you with certain applications, or you can curate your own. Whether that's a model loader, whether it's a simple algorithm like set intersection, whatever tools you need inside that platform. But it's a general compute platform, so you're certainly able to curate your own tools, your own applications to run inside that platform as well, to solve whatever problems you need to solve. And then from there, it's just setting up any other IT process. So the standard DevOps and best practices would apply across just as they would anywhere else. So very easy to set something like this up and be able to start leveraging the benefits of it, whatever your goal is, whether it's to monetize data, whether it's to create and train models, or perhaps some of the other applications that we've alluded to as well. So that's a quick overview of how this would work, and that it's very easy to get set up and deployed in your environment.
Thank you very much for sharing this information.
Absolutely.
It's a step in the direction